Hello, my name is Kenny Kirby, and this is Lab 1 Charge Tape Interactions for Physics 2. For my introduction, I'll start off with the description or purpose of this lab, which is to become familiar with the properties of charged objects in everyday settings through the use of specific charge tape interactions. And for this particular experiment, we will do that by determining the amount of excess charge on a piece of tape using Coulomb's law and Newton's second and third laws. And for the results of this lab, I found that the charge on the tape was 1.307 times 10 to the negative 8 coulombs, which amounted to 1.171 times 10 to the 10th excess electrons than we would usually see on a piece of tape. Some assumptions for this lab were to treat a long piece of tape as though it were a single point charge with all the charge concentrated at the center of the long tape, and to also assume that each U-tape made had about the same amount of charge between the U-tapes in order to determine the exact force exerted on each other. And then some fundamental principles within this lab were Coulomb's law, Newton's third law, which is that every action has an equal and opposite reaction, and gravitational force, which is pretty much just understanding that the mass times the gravitational acceleration is the force of gravity on that object. I broke down the experiment into 3 steps as far as the procedure goes. The first step was to create the 2 strips of U-tape by sticking 2 20-centimeter lengths of tape on top of each other on a surface, and then quickly pulling one off of the non-sticky side of the other in order to create the charged piece of tape. And for the second step, you're to hold your hand, a neutral item like a textbook, a negatively charged pen, and another U-tape strip near the hanging strips in order to determine the charge of the strip, whether it's positive or negative. And the third step was to attach 1 U-tape to the tops of 2 separate standing textbooks with some room for the strip to hang and hold the other strip to the bottom of it. Record the distance between these 2 pieces of tape when interaction occurs. For my observations, when holding the objects against the tape, my hand, the textbook, and the pen all attracted the piece of tape, but the U-tape against itself was repulsed, or it was kind of leaning away from the other piece of U-tape. The U-tape strips are positively charged due to the attraction to the negative and neutral objects, and the repulsion to the positive object in turn. And when I held the piece of tape with the textbooks and I pulled the other piece of tape underneath it, the top strip bound by the books floated at 0.028 meters apart. For some data and calculations, the force of gravity on the tape I calculated to be, like I said earlier, the mass times the acceleration in order to get 1.96 times 10 to the negative 3 newtons. And this in turn also became the force of the bottom strip on the top one, because the piece of tape was immobile and all of the forces on the tape had summed to be 0. The charge of the U-tape, using this knowledge, we determined that the charge on the U-tape was 1.307 times 10 to the negative 8 coulombs, and we used that in order to determine the number of electrons on tape B, which led to 8.171 times 10 to the 10th electrons. This led us to the ratio of 1 to 4.895 times 10 to the 6th atoms on this piece of tape. Some what-if questions included: if the electrons had positive charge and if the protons had a negative charge, would anything change about the observations? And I stated that nothing should change. The opposite charges would still attract each other and the like charges would still repel, generating the same results as we had during the lab. And why would it be important to handle the charged tapes as little as possible? This is because the charged tapes are able to transfer electrons to objects that they come in contact with, which would cause them to lose electrons when handling them, or when having them come in contact with a neutral object such as my hand. And finally, we have the GlowScript code that I used to generate this model. I input all of the constants and initial values in order to do the calculations like I showed earlier, and then I created arrows and spheres. The spheres being the single point charge on the pieces of tape, and the arrows indicating the forces acting on them. We can see the top piece of tape is is repelled by the bottom piece of tape, so it's lifted back up with an equal charge to the force of gravity, creating a net charge of or a net force of 0 on the second piece of tape. But on the bottom piece of tape, we have the force of gravity acting downwards on that, along with the charge. What's not pictured here is my hands holding up that piece of tape, which keeps it stable as well. Thank you.